Now we're going to revert back to some ideas that we've discussed a little bit further. And I want to delve a little bit more deeply in them so you have a little better background when we get into our statistical analyses. For instance, this first topic here is about the 5 whys with data analysis. It's easy to go and ask why 5 times and follow a path, but that's just anecdotal data. It's just the stories of people. And what we'd like to do is we'd like to turn those stories into some observable fact that can be empirically verified. So the idea that we have is what we should do is each time we're asking why, we should bound that question and support it with some sort of analytic tool. So the first time we ask why, what we're really trying to do is understand the scope of the situation. Why is something included in the problem and why is something excluded? What are the boundary conditions? What is expected? And so the types of tools we can use here are the pie chart, the Pareto chart, and then the tally sheet. And these can demonstrate the full scope of the problem, 100% of the events as we perceive them. Now, we may also have more that's not perceived, but this is just the perceived state or the starting point of the problem. So if we take a look at this, for instance, if we're looking at a call center, we might ask a question, what are all the calls coming in? Well, all the calls are not just the ones that are answered. Some may be blocked. In other words, that the switchboard is actually not able to take all the calls. And so if we just look at answered calls, we don't necessarily have the full load of people who are intending to make calls to that system. We could also take a look at the calls we do receive. Some are wanted calls and some are unwanted calls. So we have to then stratify. How do we look at those things? And this first cut is going to tell us that first degree, if you will, of rational subgrouping, the elements in the pie chart or the Pareto chart, or perhaps the components of the tally. The second why we ask is we want to understand what happened in the past. Why was this particular process outcome unusual? So we might take a slice of the pie chart, or one histogram out of the Pareto chart, or one segment out of the tally listing. And there are a number of tools we can use to inquire. We can use the individual's chart and look at the time domain. We could use a probability plot and look at the sequence of these activities as probability of occurrence. We can take a look at the process capability analysis to understand how that problem impact occurs over time relative to the promises that have been made to customers. And we can also see that as a probability distribution as well. So there are lots of things we can start understanding as we look at this using this analytic approach to data rather than the enumerative approach. So we can start understanding how good was the process? What did we actually see? That's our process capability CPK. How good could the process be? That's how we designed it. That's the CP. How much of the gap between the design process and the experience process could we actually close? Well, now we have an interesting question that we can go take a look at. When we go to the third level of why, what we want to do is understand where were those process outcomes unusual? Why did the process behave this particular way? And to do this, we want to break the process down in understanding variation within the components of the process and variation between each of those components of the process. And the tools that we'll use here are the analysis of variance, box plots to show graphically what's happening, or a multivariate analysis, which is a graphical representation of the box plot. And so what we're doing is we are stratifying the data or the process in terms of things that make physical sense in different subcomponents. So equipment type, location, people doing the work. And we'll plot the distribution of those for each of those different subgroups. And this allows us then to localize where the variation is occurring according to the different functions or components of the process. The fourth why is we want to understand then what is happening in that particular capability. So we want to determine what are the potential reasons for distinctions between high and low performers, and what could actually cause something to create the problem that we are observing. So this is where we have the fishbone diagram or the mind map, and it starts giving us all of the potential things that can influence the outcome. And this gives us a world, if you will, or an enclosed world to go inquire about and create our investigation to understand the relationships between the X's and the Y result that we've achieved. The last type of why that we're looking at here is determine what are the most frequently occurring reasons and assess those reasons in terms of their impact on cost and performance of the process. So why is this cost process performing? And here we can take a look at a Pareto plot using frequency of occurrence and cost impact. And this is stratifying then the potential causes by how often it's occurring and also by the cost of each occurrence. For instance, not all failures are equally important. Missing screws, for instance, may not be as important as a broken piece of electrical component that costs about 1,000 times more. So we have to understand what is actually happening in this process. As we go step by step, we should be refining and getting better and better knowledge of what that problem state is about. So if we use the data analysis to supplement this 5 why questioning, 5 why questioning takes us to the place, and at each point in time, we'll use a statistical analysis method to illustrate what's going on better. Now, we will show you when we talk about Minitab in just a couple more videos where these tools are in Minitab and how you can use them very easily to get information about your process and make that process become much more explicit and clear in how it's operating.